Hey everybody, I hope you can hear me all right. I'm John Starmer. I'm Director of Education at Cumulus Technologies, and thanks for joining us in our replay here cannot escape the technical difficulties. All right. Anyway, thank you for joining us. This is a take two here of this Kubernetes intro class with Robert Starmer, our CTO. I think it's going to be very informative. It's a course that we put a lot of work into at Cumulus Technologies. And like I said, I hope it's of interest and use. If you want to get all the bits and pieces of it, it is based off of a course that Cumulus presents. Um, but that's entirely up to you. I think it's going to be useful just as is. And we will be posting the broadcast up on our YouTube channel. If you are obviously watching it there, if you haven't subscribed, I would encourage you to subscribe. That way you'll know when new things are posted up. All right, so without further ado, fingers crossed, hopefully we've got a good connection with Robert here, and let's turn it over to him.
Hi, folks. Welcome to our review of Kubernetes, really the basics of Kubernetes. This is the equivalent of our Kubernetes 50 series class, where we talk about just the basics. Quick overview of the agenda. We're going to talk about Kubernetes, sort of the system, the architecture, the high-level resources, and sort of the bits and pieces that make Kubernetes work. So why is it? How do the pieces fit together? We're then going to look at getting an environment deployed on a laptop. So there's an application called Minikube, which is a really lightweight way of getting an entire Kubernetes environment up and running. So a very efficient, quick little way of actually being able to just understand how Kubernetes works. And then we'll look at building an application using the core resources, pods, deployments and replica sets, and services to actually define and access and manipulate an application in the Kubernetes model. We'll talk briefly about some advanced topics, sort of next steps to look at, and look at some of those next steps. What are the next sorts of classes or educational resources that you can look at for doing this? So often one of the first questions is, who are we? Why are we talking about this particular technology? Well, my name is Robert Starmer. I'm the CTO and founder of Cumulus Technologies. We're a systems consultancy that looks at enabling cloud and helping our customers really build cloud services that make sense for their particular enterprise or new application development environment. We also focus on a number of different technologies. Kubernetes is one area, but really the containerization of applications, the whole application deployment model, continuous integration and deployment is one aspect. Another is infrastructure services, things like the OpenStack tools and the OpenStack services models, or using that same concept with Amazon or Azure or Google Compute, for example. And we, of course, still understand the bare metal data center services world as well. That's sort of where we all came from. We are a technology company, but we also try to help people in general. So we have a newsletter. If you sign up for one of our classes, you get on the newsletter, or you can go to our newsletter page and sign up there. Learn more about the latest trends and changes that are happening in the cloud space and cloud education, especially. And we also have our 5 Minutes of Cloud YouTube channel. This is a channel where we touch on key services and capabilities in the cloud space, but we do it in very short little snippets, basically little nuggets of cloud knowledge that you can use to ramp up your cloud knowledge for yourself, or if you have a colleague who's trying to understand cloud, maybe even a manager or a senior manager who just needs the basics of what is cloud, how does it work, check out our YouTube channel, youtube.com, 5 Minutes of Cloud, and you'll get a whole list of sort of the current technologies and how those pieces fit together from the perspective of cloud. Now, the material for this recording is actually bundled as a class. We have that available on our learn.cumul.us site. Actually, the link below is probably the better one to use because that will actually get you a 50% discount on the cost of the class. This covers our cost of managing and building these sorts of things for you guys, and hopefully you'll find it useful to be able to keep coming back to the recordings, the material themselves, and we, of course, keep this stuff up to date. So as the Kubernetes resources change, we continue to update our training material along with that. So we do hope that you'll take us up on our offer to actually get this class at a discounted rate. So let's dive into the actual architecture of Kubernetes. Kubernetes is really made up of sort of two system spaces. One is the control environment. And this is based principally on the API server. This is the interactive interface that a developer or an application manager would use to talk to Kubernetes, but it turns out it's also the interface that all of the other services use to talk to Kubernetes. So the scheduler talks to the API server to understand what it needs to schedule, and the API server talks to the scheduler to actually implement the scheduling requests. The controller services, all of the sort of state processes within the Kubernetes environment live within the controller manager application. That also gets communicated to and via the API server. Within the control plane, there is another component, which is etcd. Now, etcd is a key value store, and it's a distributed, eventually consistent data store for key value information that gets used to manage the entire system state in the Kubernetes environment. It's not really part of Kubernetes. The Kubernetes community didn't build it. It came out of another company that was actually looking at building a key value store for their operating system environment. But etcd is the key value store that the Kubernetes community has chosen as its state repository. So there's no SQL class database underlying the Kubernetes architecture, just this key value store that's distributed. In our environment, we actually use a degenerate version of that, just a single node etcd, but normally you would have 3 or 5 or 7 nodes, an odd number of nodes running your etcd services within the Kubernetes environment. So we can then talk to the API server either through a RESTful interface or via the kube control application. This is a command line client application. There are also user interfaces. There's a graphical user interface that can also be used, also talks to the API server to actually implement and execute anything within that control plane. So that's the control side of Kubernetes. And then we have the effector side, the actual work engine. And there are two key components there. There's the kubelet and the kube proxy. Kubelet is effectively the control service for our pods, for our end units of compute resource or systems resource within the Kubernetes environment. So kubelet is a local manager, and it runs on any node, any compute host, effectively, any physical server or virtualized server, depending on how it's actually deployed, and actually manages the individual pods that are being deployed in the Kubernetes environment. So it's effectively the agent that is managing the individual hosts' interactions at the Kubernetes level. There's also the kube proxy. This is the other core resource that lives at the edge of the environment and effectively provides a network management interface, a network management resource. Specifically, it's actually a load balancing or service discovery and redirection technology, but it sits at the edge on every single node. And the interesting thing is, as long as I can get to a service proxy on any node, I will get redirected to the actual service that the service proxy is proxying for. We'll talk a little bit more about that when we talk about services in a moment, but these are the key edge pieces. And the application consumption, so the person hitting the website that our application provides, for example, would end up going through the service proxy most often in order to interact with our applications that got deployed through the Kubernetes environment. So these are the core components of the architecture. Now, in order for this architecture to even be meaningful, we still have to have a system underneath this, because Kubernetes, like many of the cloud tools, is actually cloud middleware. It's a set of services that sits between the higher order interactions, the API service, and the actual function of deploying a container and running a process on a Linux operating system. So at the base level, we have a Linux operating system, and often, not often, we then have to have a containerization technology on top of that operating system. Now, Kubernetes currently supports two different models for containers. Specifically, these are Linux containers of the Docker image style. And so there's the Docker image container engine. There's also the Rocket, RKT, image container engine. Both of these are currently supported technologies. Rocket will be non-beta in the 1.6 release of Kubernetes. We're still in the 1.5 release train. But they really are just engines that manage the runc container engine under the covers. And so we have to have that component enabled. Another piece that we have to have is we have to have storage, and specifically persistent storage. And when we have persistent storage, we need to have something that actually provides that storage to any and all of our compute resources. So any node that's going to run containers for us, runs the kubelet engine, also has to have access in some fashion to this persistent storage service. Now, in Google and Amazon and Azure-based Kubernetes clouds, you would end up using the distributed storage that is a part of those cloud environments. In a privately deployed service, you'd actually have to deploy your own system, and that might be something like a Ceph or Gluster, or even an NFS type service like a NetApp NFS service could also be used for persistence. But we have to enable that in order for Kubernetes to be able to provide persistent storage services. And then lastly, we need to have a network service, and that can either be a direct attached L3 forwarding class network service or some type of a layer 2 tunneling technology with a network address translation function embedded in it. There are a number of different network technologies that are available. Many are open source, and some are also commercially supported as well. So there are many ways of supporting the network, much like there are many ways of supporting the storage or even the containerization solution here. But we have to have all these pieces in place in order for Kubernetes to be able to run. It runs on top of and leverages these services. Now, there is another way that we could actually get Kubernetes running without having to manually deploy all these infrastructure services, and that is to use something like OpenStack, so infrastructure as a service, or an Amazon Web Services or Google Compute, for example. And actually, if we were using OpenStack, since I have quite a bit of history in the OpenStack space, I like to talk about it a little bit. Turns out that there are a couple of different ways of actually getting Kubernetes running on top of that. But one of the interesting things is if I use something like the Magnum project, which intends to or supports the concept of deploying pods of container management service, so Kubernetes being a container operating environment, container management service, we can do Magnum to support that, or we could just write a simple heat template or CloudFormation in the Amazon case, a template to actually deploy Kubernetes. So there are a couple of different ways of getting that up and running. One of the interesting things about using an infrastructure as a service engine, though, is that you can use something like an OpenStack, Cinder, or Manila to provide persistent storage. Again, Amazon, you'd use EBS. Google, you'd use Google Block Storage. Azure has a similar sort of a solution. And then we also have the ability to use the underlying infrastructure services network functions to also map into the Kubernetes environment and provide network directly into Kubernetes. So whether it's OpenStack or another infrastructure as a service, one approach, I'm not saying it's the right or the wrong approach, but one approach would be to use the infrastructure service to deploy our Kubernetes environment. So a pretty powerful way of automating the deployment of this additional layer of middleware for managing our containerized application deployments. So when we actually talk about Kubernetes, though, when we're talking about using Kubernetes, there are a couple of key technologies that are important to understand. The first one is the concept of a pod. Now, in Kubernetes, we don't talk about individual containers, we talk about pods. Pods are a grouping of containers that have a set of resources that are shared. And so usually this is something like one container might be the web service and another container might be the application management component. So basically, if the web service is running my application, I might have another container that just deals with updating that application code. And the nice thing about doing that, grouping these containers together, is first off, they can share things like network namespaces, and actually they have to share the network namespace. But they can also share storage resources or even interprocess communication namespaces. And by doing that, the pod becomes a more powerful resource because I can actually separate some security concerns. For example, my application management container can have specific private keys or security keys to allow it to download code from upstream resources without putting those keys in exactly the same space as our actual web service that actually has end users talking to it. So I've created some security separation, and at the same time, those two containers can share, for example, an underlying storage layer so that the update container can update the same storage layer that the web service container is presenting. Now, it's not a full sharing. It's not like the two containers are merged into one. They still have their separation of container level resource, the classic container segregation of process resource, but they have access to shared resources as well that are also then segregated at the pod level. So the pod is a very important construct, and we talk in Kubernetes about deploying and managing and manipulating pods, which might be one or more containers. Now, it turns out that on top of all of this, pods are always multi-container because there is a container specifically to manage the network namespace that is always running in any pod, even if it's just a single container, in other words, a single end user deployed container within that pod. So that's the concept of a pod. Now, pods are intended to be scalable. The whole concept behind Kubernetes is supporting this scalable web scale distributed application services model. And in order to support scale, there are a number of capabilities, but the most important at this point is now called the replica set. It used to be called a replication controller, but the replica set has actually been broken into the replication component. How many of a service should I have, or how many of a pods should I have? and what sort of state should I know about those pods, and the concept of dealing with change in those pods, sort of the life cycle of those particular pods that are in that replica set. So the replica set just deals with scale management. How many should I have and where should they be? So it does that where should it be by talking to the Kubernetes scheduler, but the how many should I have is part of the replica set scale engine. Now, the second part of this is, of course, this concept of deployment lifecycle. And so there is a deployment resource that deals with lifecycle and resiliency. You said I should have eight of these particular pods running. The replica set tries to make sure that there are 8 in existence and 8 running. The deployment says, yes, but I would like those to have a new version of one of the container images within the pod. So basically update the pod specification on all of those. The deployment tells the replica set to increase the number of a new pod and decrease the number of an old pod, and sort of manage that life cycle shift in terms of effectively a rolling upgrade in the process. So that's the service of a deployment. And in general, in Kubernetes today, we're talking about using deployments as our general interaction with the system. So we talk about deploying a pod in a deployment, which also creates a replica set. So even if I deploy a single pod in a deployment, I will have a replica set with a replica of one pod in it. And so that's the core resource model within Kubernetes. Now, there are lots of different ways of using replica sets. There are other ways of approaching this entire process of starting a pod, but usually you're using something else. You're not deploying pods individually, and often you're not even deploying replica sets individually. You're using something else to create and manage those resources. Now, one of the interesting things in the Kubernetes space is this ability to actually manage services, basically another way of finding and discovering resources in a very efficient fashion by using a resource known as a service. The reason that this exists is that if I have multiple nodes, multiple compute nodes that are actually running my pods and then the underlying containers, but I'm scheduling those resources dynamically and potentially I'm increasing or decreasing the number of pods at any one point in time, I need some way of managing the discovery, like where did this pod exist or where does this pod exist that I want access to because I've just added another resource or removed a resource. Well, the service is the resource in Kubernetes that handles this. It handles the concept of balancing load, so making sure that if I talk to the service and the specific service endpoint address, I can actually distribute those resources and those requests across a number of different targets for the system. It's actually a pretty powerful tool and embeds the concept of load balancing at the service level. It also deals with discovery and mapping of those resources against a deployment. So if I need to understand where I might have my specific web app resource, and how I might actually talk to that, I would ask the service constructs within Kubernetes where and how to communicate with that capability. We'll play around with this a little bit in a moment, so I think you'll get a chance to see how the pieces fit, but that's the concept of a service. Lastly, there's this concept of a label. Now, unlike the pods and replica sets and deployment and services, labels are not resources in the Kubernetes service, but labels, and then specifically the key value pair model that makes up a label, is how everything gets allocated, how everything gets connected in the Kubernetes world. For example, a service gets created and can be created without any associated deployments or replica sets or even pods to associate with. The way that the service knows which resources to actually understand and therefore register and present when somebody asks about a service target, it does that by looking at a label that matches between what the service is expecting as a selector, let me select a set of resources, and then the something like the name of a pod or the name of a deployment as a way for the service to actually discover those resources and information about them. So again, we'll look at this at a very high level in this particular class, and we can get into a deeper dive in our future classes about this technology. But the service defines this, and all of this interaction comes at the benefit of labels. So we can look at labels as well as a key resource. So in order to actually do anything with Kubernetes, in order to get one of these deployments or a service running and sort of associate labels between services and deployments in order to make that connection, we actually have to get Kubernetes running. And there are a number of different technologies out there for actually enabling this, but the simplest is a tool called Minikube. It's really intended exclusively for this kind of use case, just sort of a demonstration, an understanding of how the pieces work together. It certainly is not intended to be something that you would use for a production use case, and in fact really only supports a single node, so it really isn't appropriate for a production use case either. In order to do this, Minikube needs a virtualization target. We're using VirtualBox because VirtualBox works on all of the possible laptop types that I've run into. So we can do it on top of a Linux laptop, a Windows laptop, or a Mac laptop. And all three of those models actually work just fine. If you have a Google Chromebook, then you really need to look at a different solution. But in our cases, at least, usually VirtualBox is the right solution. So you can grab that from the virtualbox.org downloads page. If you grab that, don't forget to also grab the extension resources. They're on the same downloads page. There's one extension resource for all systems types, but there are individual downloads for Mac, Linux, or Windows machines. So if you don't already have it, get a copy of VirtualBox. If you have another virtualization technology like VMware Fusion or maybe VMware or Parallels or VMware Workstation or one of the other virtualization technologies for laptops, you may be able to use Minikube with that. I haven't tested it, although there are extensions that have been called out so that you could potentially talk to those resources. For this particular walkthrough, though, I recommend you get a copy of VirtualBox. Potentially the latest version makes it the cleanest. We'll also need to get Minikube. So you can get that. There's a getting started document that's listed here. But download the Minikube application onto your laptop. And then we're going to actually launch that from a command line client, whether you're on a Windows machine or a Linux machine or a Mac. You'll actually need to open up a terminal session in order to actually launch the Minikube application. We'll also need one other tool, which is the Kube Control application. This is the tool that you actually use to talk to Kubernetes, and we'll need that for the Minikube resources. That information is also available on the Getting Started guide, basically where to download the Kube Control tools. Just as a little hint for those of you on OS X or Mac machines, if you have the Brew or Homebrew tools installed, you can Homebrew install Minikube and Kube Control. So that's another quick way of actually getting that within a Mac system at least. Now, if we actually want to do Minikube, make it do something, the first thing we need to do is we need to actually launch our Kubernetes environment. So as an example here, we can actually launch this. We can do Minikube start. Well, we can do status first just to see what it says. And it says, look, I don't have the virtual machine deployed, and I don't have my Kubernetes environment deployed yet, so that I can't talk to it. So we can do Minikube start. And what this will do is it will first download the little Minikube ISO file, and then it will launch a virtual machine within VirtualBox to do this. Notice we don't actually have to start VirtualBox. We don't have to manipulate the VirtualBox environment at all in order to actually use this system. We can just go ahead and launch Minikube, and away we go. We have all the resources set up. The Minikube engine will also configure our Kubernetes control tools to talk to that Minikube Kubernetes environment. Now, this is something that if you're talking to a remote Kubernetes environment, you would actually have to end up manipulating how kube control actually talks to the system. But there's also a web-based interface that Minikube will also help you launch to actually also to launch these sorts of resources. But Minikube's going ahead right now. It's actually launching the virtual machine. This takes just a minute or so on most laptops, and then we'll have our Kubernetes environment running. So now we're just making sure that the system is actually set up, and this takes just, again, another minute. This is actually setting up the Kubernetes resources. And part of this is using Kubernetes and the Kubernetes models, things like managing pods and creating pods with deployments and services. It's actually doing this in the background against the baseline Kubernetes environment. And there are a number of components as you look at more advanced ways of deploying Kubernetes where you can actually manipulate exactly the state of the system and the resources and the background tasks that are occurring just by managing and manipulating the service at this level in the cluster level. So again, this is doing additional downloads inside of this Kubernetes Minikube virtual machine. We're now downloading a set of container images that are going to be deployed as different pods and resources in that Minikube system in order to actually run the Kubernetes environment. And this is things like, first off, getting the kube control tools installed, and then making sure that we have the latest version of the upstream Kubernetes services, things like an embedded DNS service and potentially a networking resource service. All of these pieces have to be installed and running in order for the system to work. Now, part of the question is how fast is the network to actually implement all these different tools? And so what we're seeing here is the fact that apparently my network today is a little bit slow in actually downloading and installing these capabilities. One interesting aspect, of course, is that once this has been downloaded once, even if we stop it and restart it, the restart process actually happens a lot faster the second time around. I probably should have done that, but I wanted you to actually see the whole download process and all the bits and pieces sort of coming together for this particular Minikube deployment. All right. So with that, we now have a running Kubernetes environment, and we can validate this. First off, we can ensure that Minikube is running by asking it what IP address it has assigned. Now, this is an address that is assigned within our laptop environment. So within our laptop, we can hit this 192.168.99.100 address, and we can actually get information about the running system. And that includes things like we can actually create a user interface access into this system. Let me just get a little browser set up here. Something that actually fits in our window. And we can actually say Minikube dashboard. What this should do is launch within our browser access to the Kubernetes IO dashboard. So this is launching against that same, here's our Kubernetes address. This is the Minikube address. Port 3000, it turns out this is a Kubernetes service. We'll talk a little bit more about that. And we're now talking to this service, which actually implements this dashboard. Here we see this concept of deployments, replica sets, daemon sets, pods, a number of different capabilities for how you actually manage your services. As I said, there's more than just deployments and replica sets, but these are the current set. And there are still replication controllers separate from replica sets, although this is being deprecated for replica sets and deployments over time. But with that, we now have a running environment. So we have our engine here running little mini Kubernetes. We have our kube control get nodes, and we'll see that we have one node, which is the Minikube node. So kube control is the command line way of interacting with the system. We have our little web page here, which is also interacting with the system. And we can actually now use this system to do meaningful work. So if we then want to move on from this, we could even look at the underlying Docker resources, but we're not going to do that. It's just something that you could actually do. But we now see that we can talk to the system. We have our dashboard running. We actually also talk to the Kubernetes environment from the node level. So the first thing that we want to do, some of the code should be available still here at the DevCube 100 page, except that this is a Cube 50 class. But as the basics for this, we have this basic information. We can also, we'll do the first thing, which is to create a pod. Now, normally you don't create a pod individually, and so we actually have to create a specification file to describe this pod. It turns out that if I just wanted to launch a single container in a pod, I would actually do that by creating a deployment automatically, which would manage all these different resources together. In order to create a specification for a pod, I have to create a spec file. That's the way it's normally described. In this case, we're using the YAML, yet another markup language name file type for doing this. YAML is interesting in that it's white space delimited. So these spaces, for example, in the metadata key, this value of name or key value of name in Nginx, I have to have at least one space, and then I have to have consistent spacing within that section. So here in the spec, for example, again, I have to have two spaces in front of every one of my resources. Now, once I've created this list, I actually have a further hierarchy, and so then I have now, instead of two spaces, I have four spaces, but I have to make this all specifically consistent as well. If I have an extra space, or change a spacing here, that actually breaks the YAML file. So it's very important to have this spacing right. And once I've done that, though, I can go ahead and actually launch this pod from the specification file. So here, there's some basic information. Which version of the API are we using? We're still mostly on version 1. Some services are on version 1.1. What kind of resource am I creating here? In this case, I'm creating a pod. What metadata, so basically what labels am I creating? Some metadata like name is a default label, so I don't have to actually specify that this is in the labels section. But we're going to call this pod an Nginx pod. And partially that's because if we then look at the specification for that pod type resource, we see that we have our list of containers. In this case, we only have one. So even though there's a dash here, this describes a list in YAML. It's a list of one item. And that item has an image. So this is the upstream name of that image, and I could include a version with this as well, but this is just saying, give me the latest version of the Nginx container from some upstream repository of Docker images. In this case, we're using Docker Hub. That's the standard of what gets used. A policy to say, hey, if I deploy this pod, always get the latest version of that image. Always pull down a new copy of that image. Don't just use the one that might have been cached somewhere. Also, I want you to call this container, and this is separate from the name for the pod. This is the name of the container. I want you to call this container Nginx. And then I also want you to expose port 80 out of this pod and map it to this particular Nginx container using the TCP protocol. This describes our pod, and it enables us to have a little pod that expresses a port 80 enabled web server, Nginx being a web service container, within the environment. So we can actually go ahead and do this by launching this particular pod. And so here you can see we already have our pod specification, right? This is the exact same file we just looked at, and we're going to use the kube control command. We're going to tell it to create a pod. We could also do apply, which is also a way of updating a pod, but this is an initial one, so we'll just create it, and we can say pod.yml. So what this has now done is this has created a pod called Nginx, right? And in that Nginx pod, there's a container called Nginx as well. So a little bit, maybe I should have called it container Nginx instead of pod Nginx or something like that. But anyway, if we then get our list of pods, we see that we have an Nginx container and it's currently creating. Now, what this is doing is it's actually, again, pulling the image of the embedded container in the Nginx pod. In this case, it's a single container, so that's just trying to pull down this one container. We can also do kube control describe pods. This will give us an entire list. We only have one pod, so this is effectively like telling us to describe the Nginx pod. And you can see that this is the sort of set of events that's ongoing for this particular pod. First, it was scheduled. We asked the scheduler to schedule it. It was assigned to the Minikube node. Well, it's the only node we have. Then it said, hey, I need this container because that's defined in the pod. So I need to get the Nginx container. I pulled it successfully, and then I'm going to go ahead and create a Docker resource, a Docker running container from that image that we pulled down from the Docker Hub. And lastly, our pod is actually running, and that means that we now have a successfully running environment. So if I get pods now, you see that I have 1 out of 1 required resources ready and running in my pod environment. We talked about other resources as well. So we could look at like replica sets. And we can see that there are no replica sets. We also talked about deployments. We can see there's no deployments. And we can also check services. And we can see, oh wait, there's a service running. There's a Kubernetes interface service. And this is actually important because this service is how our kube control tool is actually talking to Kubernetes. So this is a service that will always exist in our environment. And it's an important one that's a part of the Kubernetes engine running. So we certainly don't ever want to delete this service, even though we have direct access and could certainly do that. We're going to go and create now a deployment in a pod of our own. So since we have this, one thing that we might want to do, though, is a single pod might not be enough. Maybe we want 2 or 3 or 4 web services running so that we can deal with scale. In order to do that, though, and even before I create a service for discovery, I need to create this as either a replica set or a deployment. And so the first thing that we're going to do, because we're good cloud citizens, is we're going to delete our pod, and we're going to do that by giving it the same specification we used to delete or to create the pod. We're going to delete it with the same resource. Now, one of the interesting things about deployments, because they are now the sort of the default model for deploying even a single pod, is that we're actually going to run. We can actually tell it to run a pod or deployment rather, and we can give it the name of that, and then we can tell it what image to use, and we can even tell it what ports to expose against that image. Now, this only works if I want to run a single container pod and specifically run that in a deployment. But what I can do is when I launch this, now I've created a deployment called Nginx. So if I do kube control get deployments, we see that we have one. It's currently one is currently running. It's also up to date and it's available. Now the reason it's available so quickly is because I didn't have to download the image again. In this case, in my pod description, if I described it at the pod level, I'd have to re-download the image, so it would take it a couple seconds to download the image. In this particular environment, since the deployment doesn't have that specific pod specification that we created, it will just automatically reuse the Nginx container that we have. Now, one of the interesting things is that we also have the ability to now manipulate this environment. We can also check, by the way, it turns out that not only do we have deployments, but we also now have a replica set. And that replica set says, hey, I'm expecting to have one replica of my pod, and I currently have one. We can scale our environment, kube control scale, deployment Nginx, and we can say that we want to have 2 replicas instead of just one. So now we've scaled this, and again, we can see what's going on here by saying, hey, show me more deployments. Hey, now I'm supposed to have 2 instead of the previous one. I currently have 2. They're up to date. Everything's happy. If we go check our replica sets, sure enough, we have 2 resources in our replica sets. And if we check our pods, I should have checked that earlier, we can see that we now have 2 pods running. If I change my scale from 2 back to 1, I can actually see that I only have 1 pod running. Now, all of this happens very rapidly because I'm dealing with containers that I can start and stop almost instantaneously. If the container was actually doing something and I had defined it as such, the container would actually shut down cleanly before I deleted it. So it might actually sit around a little bit longer than what we're seeing here. But this is how we actually start to manipulate these resources within the service environment. So it's very useful to see exactly how the system is actually functioning in this particular case. Now, we can also create deployments rather than using the run command. We can actually create a file, another specification file. And that specification file, rather than having a specification that just covers the containers, we actually have a specification that first off covers the deployment and the replica of those deployments, so the replica set associated with that deployment, and then the replica set has as a sort of a sub-resource the specification for the containers, in this case the single Nginx container. So this is great. One of the interesting resources is that we can actually, once we have something running, we'll go ahead and do this. We're going to evaluate this environment, so we can say docker ps. You can see we have lots of things running. So now we have to try to discover our Nginx container within this. If we do describe. Right. In our case, we started this one container, and we expect this one still to be running. So we can do docker ps, and we can look for this particular container ID. And so here's our Nginx container and our actual container ID. And again, this is using the underlying Docker resources pointing into our Minikube system, talking to the Docker daemon underneath Kubernetes. So the same thing that the kubelet engine is doing. And one of the interesting things that we can do is we can actually cause Docker to delete the resource. So we can say Docker stop this container, and we can say Docker remove this container. And if we now say, if we look for that container now, we'll see it doesn't exist anymore. If we go and we look at Kubernetes, we'll see, hey, wait a second, I had created this container and it was running, but I suddenly see that something has failed and I have to create a container again. Now, we don't see that anything failed. It's not telling us that. We can try... we can see here that I increased or decreased the system. Nothing here tells me that a new resource was created, except for the fact that my container ID is different, right? So if I again ask for my pods, now if I look for this pod at the Docker level, we see that, again, I have my Nginx daemon running against this particular resource. So the underlying resource said, the replica said I should have one replica running. The pods expected to have one replica running. And when the pod failed, when the underlying container within the pod was deleted, the pod specification itself said, I expect to have one pod running, so I better have a pod running. Well, I don't have a pod running if my container's gone, so let me start another version of that container, which is why we have a different container ID for that resource. So we can see that the system is trying everything it can do to keep itself alive. But there's one other piece to this, which is that even though I said, hey, port 80 should be available for my deployment, I still don't have a way to talk to it. In order to do that, I have to create a service. Now, a service creation process is actually fairly straightforward. Here, we're just going to say, I would like to expose port 80 against my Nginx deployment as a node port. Now, a node port is a specific type of service that expresses the port and maps that port through the service proxy, that kube proxy that we talked about at the very beginning, as a way of mapping these network resources together. It exposes that resource through the kube proxy so that the pod will get exposed on port 80 on the node. I can only do this at the deployment level because the deployment then has a load balancing service behind it. Any number of pods can then be spun up, but I still will only present that on one port on one node. Now, if I have multiple nodes, these being multiple compute resources running my Kubernetes containers, I can actually have that port expressed across multiple resources. So it's a very powerful tool. And again, we're going to go ahead and do exactly this. And we're going to say, I would like to expose this and create a service. So now, control get service, we see that we have two services. We have an Nginx service, which has a cluster IP, but it also has two ports that we can see here. We see port 80 and port 3459. Well, it turns out this is our node port. We know our node is minikube IP. This is our node IP address, so we can actually now run curl against that address, 192.168.99.100, and the port that was specifically created for this service, and we should actually get the response from a default Nginx service. So here, this is a web page that Nginx, welcome to Nginx, actually presents to us. Now, the interesting thing is that we can still impact this same resource if we go ahead and scale our environment up. Run back here to scale. Let's make it replica 5. So this will actually turn on 5 replicas. We see now we have 5, and it's still creating, some of them are still taking a second to start up. But now we have 5 of these resources, and you can say, well, how am I ever going to figure out if this is doing anything? Well, we can actually start looking at logs. And we have to ask for an individual pod's logs. And we can see that so far, none of these pods... wait, I did actually ask that one machine. This is the one that you can see it restarted once. That's because we killed the underlying container. So the system does know that something happened, even though it just said, well, I just restarted it. So that's all I had to do. But we can see that if I actually asked the system, I was actually able to query this particular node, and I got a response. Well, if I do this multiple times, what we'll actually see is that over time, we'll have logs on multiple resources. So we can see if the first one has a log file now where it didn't before, and we can check the other one as well, and we can see that the system, which was the first resource, has also been hit a couple more times. So what we're seeing is that the system is actually load balancing. Even though I have only one service type, one service interface, the load balancing is also automatically being created for me. So this is the power of Kubernetes. It handles application scale. It gives me an endpoint that I can give to my end users to actually access my resource, and it does all of that through these different service constructs. So that's really the crux of how Kubernetes works and how the different resources interact. We've done services. We could also here deploy a service with a specific specification. And here you can see the node port. We could define it. In our case, when we used the expose model, a node port was selected for us. And we can discover that either by looking at the service and seeing what the service describes itself as, or we can even query the information to actually get the specific resource and component. One of the interesting things is that a deployment is one kind of resource and a service is another. And in this case, we can actually create a single file that has both the deployment and the service information in it together. So if we go and clean up our environment, kube control delete nginx. Right, so it's deleted, which means that our curl no longer works because we no longer have that service available to us. And we can also kube control delete deployment nginx. Helps if I spell deployment correctly. And this takes it a second because it actually also has to kube control get pods. We see no pods left. Get replica sets. We have no replica sets. RC is a short for replication controller. RS is a short version of replica set. So there are some contractions. Kube control get will give us a kube control get will give us a list of all of the different resources that the get command actually understands, and the short versions of them as well get listed there. So we could actually then redeploy this service as a single file. If we look at our nginx example file here, we see that here's our basic deployment description. Again, our container on port 80 as a specification in the replica for our deployment spec. And then our service description here, we're calling out a specific port, 32501. If I create this, we can see that our service is created. In this case, it actually used the port that we specified because there wasn't anything else on this port. And so now we can actually run curl again, and we should again be able to get access, except that we need to go to 32501 instead of the other one. And again, we're talking to nginx, get logs. Actually, have to ask our pods. So we'll see which of these the system actually talked to. M4GPT. And sure enough, there we go. And if we hit curl a couple of times, we should see that we're talking to each of these systems. Well, maybe not. Maybe we aren't all talking to one instead of the other. And sure enough, now we are actually load balancing a little bit as well. So load balancing isn't necessarily equivalent, but it certainly all works. We've already seen things like understanding what the system is doing and seen logs. The other thing that we can do is we can actually talk to the actual underlying container, assuming that I have an executable that I can talk to. So we can talk. So we're going to exec against the pod nginx. 344-933-8310. As long as there's a bash executable in this container, we should be able to actually talk to it. And now you're going to show me how. Oh, yeah, it helps if I tell it that I want it to be an interactive interaction. So I'd like a terminal, and I'd like it to be interactive. And now I have bash within the container. So we can see that we have an nginx process running, and this is within our container environment on top of our Minikube system. So that is sort of the other thing that we can do if we actually need to get into the container. Usually we don't want to do this, but in general we have that capability. We also have other things. We can start manipulating I really wish I could spell. We start manipulating things like namespaces, which are different ways of labeling our resources. It's a way of segregating resources. If we actually look again at our system, you can see that we have two namespaces. And when we're looking at things, we're looking at the default namespace, but we can get pods against the namespace of Cube system. And we can see all the system resources that are running. So we have you can see all the systems that we're running. So we can see that we have things like an add-on manager, DNS, and a dashboard running as well. So with all those resources, we have a very efficient and scalable system. So that's the basics of Kubernetes. With this, you actually have the knowledge of deploying containers, deploying resources, deploying the services along with these capabilities. Now, of course, there's one thing, which is that you can go ahead and get access to this material as a class by jumping on our training discount, or obviously you have this recording, and this will be made available on YouTube. So you have this as another way of getting access to this. There's a lot of information on the Kubernetes.io site as well, some of the basics, and there's a nice introduction from DigitalOcean. There's a lot of information about basics of getting started with Kubernetes, so there are lots of different ways of doing this. Obviously, we like our class, and so we think that would be a great way for you to do that, but that really depends on you and your needs. We thank you so much for actually attending this. If there are questions, we can take them either in the comments section, which we'll respond to over the next couple of days. We'll keep coming back and watching that, or you can contact us directly on our website as well. Again, thank you so much for your time, and hopefully this was a useful resource. We'll be doing more of these in the future.
All right, guys. Thanks. I think that went spades better than the last time. Hopefully this was useful to you. As Robert said, we have a 50% discount, so that takes this class down to about $50. We will be posting the recording of this video. The class basically gets you a little bit more structure, gets you easier access to some of the resources, some of the files. So either way, you have access to the content. I think that was an awesome presentation. Thank you, Robert. And we look forward to seeing you again soon. We are going to have a Let's Do Lunch, one of these smaller kind of gatherings to do some face-to-face networking sort of stuff. We'll have a discussion around a topic that you guys are welcome to input. In fact, I will be sending out a short notice asking both for your input on this sort of a tutorial style meetup session. If this was useful for you guys, we'd like to know what you guys want to see. And we are looking towards having some presentations from people other than Robert here in April coming up, so look for those as well. Once again, thanks for attending. I hope this was useful, and I will put up a short link here in just a second if you wanted to check out the discount, get a little bit more information about what the Cube 50 class is all about. All right, so have an awesome day. Thanks for joining us.